All right. Last but not least, I'm excited to welcome Mohan Muppidi, Principal Cloud Architect Machine Learning at iRobot, where he focuses on ML platform that hosts data and compute infrastructure. Today, he'll be talking about the good, bad, and ugly sides of managing and using Kubeflow pipelines for machine learning research and development. Welcome, Mohan. Over to you.
Hi, I'm Mohan Muppidi. I work as a cloud architect for machine learning group at iRobot. If you haven't heard about iRobot, we are the largest consumer robot company in the world. We've sold around 350 million robots. Our frontline product is Roomba. We are the makers of Roomba, and we've been around for 30 years innovating in the field of robotics. Some of the robots that we built are, of course, Roomba, Brava, Luz. We have some military robots like Packbot, and also some telepresence robots. Currently, we also have a line of robots that supports edu robotics. Today, I'll be talking about our ML platform infrastructure focused mostly on Kubeflow. I'll be talking you through our experience, why we chose Kubeflow, how we managed to deploy it, maintain it, at the same time how we are getting some value out of it. Finally, I'll be talking about the challenges that we ran into while managing this infrastructure, how it all worked out for us. So before we talk about Kubeflow, I just wanted to briefly talk about ML platform, what our wish list was when we started shopping around for different platforms that are available. Initially, we had some ground rules in our mind. Some of those things are we don't host any models. All our models run on the robot itself. So our models are embedded models. All we needed is like ML platform to have some kind of an orchestrator. Then our ML platform will only be used for research, development, and testing efforts. No hosting again. Single platform for data and machine learning modeling needs. We are a small team, and when it comes to managing infrastructure, as you all know, it's not that easy. So we've decided that whatever we build here or whatever we deploy here should be useful for both these purposes. It provides benefit in two ways. One way, you don't have to learn n number of tools. At the same time, it reduces the operational burden on your team itself. So we wanted to have a single platform that supports data and machine learning modeling needs. Our primary users are mostly data scientists and machine learning scientists. We don't have like specific people who build data sets, specific people who curate the data. Data scientists and machine learning scientists are the ones who actually go through the data, select the data they want, build the features that they want, or will select the subset of data that they want to get annotated or anything along those lines. So they are the ones who will be running these data processing workloads or machine learning, modeling, and training workloads. We wanted the platform to be Python centric. Being a robotics company, we are heavy on C++. But as you all know, machine learning, Python is the king of the languages when it comes to machine learning. You have a lot of support, you have a lot of you have a lot of frameworks that support Python. At the same time, even the infrastructure side of things are also very well supported from Python side. So we wanted it to mostly be Python centric as much as possible. That's a little bit of background, and let's talk more about the end user features that we wanted. As I mentioned earlier, our ML scientists, our users are primarily ML scientists and data scientists. We wanted them to have a secure workspace where they can go and play with this secure PII data without having to worry about privacy or compliance requirements. This will help them. We wanted this platform to be a place where they can go worry free about am I going to leak this data, or is this platform safe enough for me to do this kind of processing. We wanted them to have the secure sandbox which had enough guardrails for them to go and do data processing or training or anything along those lines. We wanted the infrastructure to be abstracted out from the user. Simply the reason being, we don't want them to go and build cloud architectures. We wanted them to go and build machine learning model architectures. So we don't want them to play with cloud formation, or we don't want them to understand IAM or anything along those lines. Before I continue, I just want to mention that we are mostly AWS shop. So most of the references I make here are going to be around AWS cloud. So please keep that in your mind. And another thing that we really wanted to have in our infrastructure is some way to like reproduce and repeat our experiments. And as you all know, Docker is the best thing to do that. So we wanted this platform or this framework that we choose to have Docker support, extensive Docker support, so that we can get the repeatability and reproducibility baked into our workflows. Infrastructure should support pipeline or workflow orchestration. And then finally, we wanted the infrastructure to be scalable and economical, as most of you want as well. So that was our kind of wish list and goals when we set out to like go and find a platform that actually helps us with our machine learning efforts. And that's when we ran into Kubeflow. We looked at several orchestrators or several services that are offered by cloud providers, not only AWS, we also looked at other cloud providers as well. Looking at all of them, none of them had the maturity that we expected and all the set of features that we expected. But Kubeflow seemed to have most of them at that point in time. So if you haven't heard about Kubeflow is a ecosystem of tools that is built to run on top of Kubernetes. The goal of Kubeflow project is to make running machine learning workloads easy on Kubernetes infrastructure. So they have several projects within Kubeflow. For example, there is Pipelines project, which will allow you to run workflows on top of Kubernetes. You have Khatib, which will allow you to run hyperparameter tuning, and there are several other projects that do something along the lines of serving or model hosting, metadata tracking, and things like that. So when we looked at this, here are some of the boxes it really ticked. We wanted something Docker based. Okay, that's something that's provided by Kubeflow. We wanted pipeline support. Okay, that's available. We wanted some flexibility, flexibility in the platform so that it can be used for both data and ML needs. And Kubeflow Pipelines actually offers you that. If you've already worked with it, you know this. It's just a Docker container or a bunch of Docker containers running together or orchestrated in a certain way. So it allows you to do that. And we wanted infrastructure abstraction. So this actually provides you that. You have a Python SDK and you can kind of just communicate with that Kubeflow server and just forget about Kubernetes or anything else that lies underneath it. And then it's scalable. But there are also some places where we thought Kubeflow did not really satisfy all our needs. For example, here are some of the things that we felt like Kubeflow was lagging. I mean, it's not lagging, but I would say it's lagging from out of box solution point of view, right? It doesn't provide you these things out of box. Of course, you can build them around Kubeflow to make it more make it satisfy all these needs. But it wasn't providing them out of the box. So some of them are around, security and privacy compliance requirements, some authentication. So it's like when you're working for an enterprise, you want to use a single sign-on to access the Kubeflow or any type of tool instead of having different identities or anything along those lines. So that wasn't really existing. And then we wanted to have some sort of data persistence across our deployments. So it could be we deploy updating the Kubernetes cluster, or it could be we updating the Kubeflow deployment itself. We want to make sure the metadata that Kubeflow relies on persists across updates. These are some of the things we felt like it did not exist in the out-of-the-box solution that Kubeflow project provides. So we had to build some of them ourselves. Of course, this is not completely Kubeflow. It's also the underlying infrastructure that has to provide all of these things for you. So we worked with AWS teams, and within our team, within our company, worked with the privacy and compliance teams, security teams, to ensure that we get the right mix of things. And this is the architecture we came out with. So to start with, we have a SAML identity provider that we usually use within the company. We wanted to integrate it with Kubeflow, so we made sure we had a solution for that. So we were using our SAML identity provider to connect with Cognito as a SAML identity provider, and then Cognito works with load balancer to allow us to go and access Kubeflow. When it comes to the network infrastructure itself, as I mentioned earlier, this infrastructure is something that we wanted to use for processing high sensitive data or PII data. So we wanted this to be kind of in a place where it's not hacked by someone easily or anything along those lines. So for that reason, what we wanted to do is we wanted to have an isolated VPC, and this VPC should have instances that only run in a private subnet. That way, no one can access our pods from outside, but only if someone is within that private subnet, they can access it. So all our pods run in this private subnet, which makes it a lot secure. At the same time, if we have to go out and get data or packages or anything along those lines from outside, we have a firewall solution attached to these private subnets, which will allow us to make sure we guard against threats that can come that way. So that allowed us to kind of make the network infrastructure secure. At the same time, it also allowed us to connect to our corporate network, as this is much more stable network. Once that is done, we wanted to, as I mentioned earlier, we wanted to have this data persistence across deployments for the Kubeflow infrastructure. For that, we had to add some stuff around RDS, which is a database that's sitting, and Kubeflow communicates with this database and writes the metadata there. That way, the metadata itself is persisted. And we also had an elastic file system in place so that we can store any artifacts that Kubeflow needs to store. So as you can see in this diagram, we use EKS for managing our Kubernetes cluster, and then we deploy Kubeflow on top of it. Once we've done this, one of the things that we really wanted is to have a GitOps kind of workflow. So we've decided that any change that goes into our cluster, our Kubernetes cluster or Kubeflow deployment, it has to go through a GitOps workflow where all the changes are tracked within a Git repository, and then those changes, once the changes are merged, a pipeline is triggered, and this pipeline will take care of the deployment for you. And then once that is done, your Kubeflow is ready for you to access it. Let me spend a little bit of time here. So this pipeline, it primarily uses AWS code pipeline to ensure that the deployment can be done properly. And then it uses a bunch of code build and other services. But as you can imagine, it's not always easy to have all the changes go through this Git repository, because there could be an issue within the cluster and you want to debug it and quickly fix it so that pipelines can run properly. Or there could be other instances where you're doing some debugging and you want to deploy something ad hocly pretty quickly, and then once you're done, you want to delete it. So we know that we are a little bit flexible about that in the sense that we sometimes go test stuff directly in the production cluster, not things that can kind of break everything, but it's just if it's a additive thing to the cluster that provides you some value that you just need for some time. Let's say, for example, we wanted to allow metrics for certain type of parts to be streamed into a monitoring service. And once that is done, we don't want that feature to be enabled for some reason. In that scenario, yeah, we do have that flexibility to go deploy it and remove that deployment. But if you want anything that to be persisted, we just go implement it in our repository as an automated workflow or as an automated part of the deployment pipeline, and deployment pipeline takes care of it. Yeah, that's a brief overview about our deployment infrastructure that we have for Kubeflow. Once we deployed this, we initially, as with any platform, the initial traction was not there. Of course, there are several reasons for it. I'll go and talk about them. But some of the things are around you have the infrastructure, but your machine learning engineers and scientists, they have been using certain type of development workflow for their models and for their dataset building for like past 2 or 3 years, and now you want them to use this infrastructure. Of course, there's going to be some lag before they can try to adopt this infrastructure. So that is what has happened. But what some of the things that we've done there are we try to make sure that we educate people internally. So we conducted several workshops, get them familiar with these concepts of Kubernetes, Kubeflow, what's a pod, what's a container, how to use Docker for some of the workflows that we want to do, and just like making sure they're up to date with what this infrastructure can offer. And then slowly started building some workflows for them, just as an example, and also provided a bunch of samples that allows us to like show how this Kubeflow infrastructure that we developed integrates with several resources that are available within iRobot and outside of iRobot as well. That actually help them to like have a way to like educate themselves in this new infrastructure. And whenever there is a time crunch situation and they cannot scale their experiments on their regular development workflow, they just started adopting Kubeflow. Once they started adopting Kubeflow, they slowly started building more and more pipelines, and that is how things have evolved. Here are some of the examples that we have. As I mentioned, we wanted to use Kubeflow for data workloads and also machine learning, training, validation, and any of that, those workflows as well. So we have some pipelines that help us with data ingestion. We have some data ingestion into our data platform. We have some pipelines that purely do model training. We have some pipelines that do data processing, dataset building, model training, validation in a single pipeline. We do have some pipelines that help us with annotating data automatically using some kind of criteria. And then we have some pipelines that go tag data for different purposes. It could be filtering out data that can be used for annotation, or filtering out data that we can use for data building data sets, or anything along those lines. We have pipelines that build data sets. We have pipelines that do some ad hoc jobs, like maybe move data from one place to another so that other team can use it. Or it could be something along the lines of move the data so that our third-party labeling partners can access the data and get us the annotations that we require. It could be something like, I want to quickly build this data artifact out of all the data we have, they go use it. We've also explored Khatib service within Kubeflow for hyperparameter tuning. It worked pretty well. Of course, it required some effort from the ops and machine learning scientists, but at the end of the day, once you get it working, it all works. But it still needs some work to make it more usable, in my opinion. But it definitely works, and it gives you the flexibility to like bake in your own things, which definitely is helpful. Okay, so talking about Kubeflow, what do we love about Kubeflow? So here are the things we love. We can build Docker-based workflows using Python, which is great. We can scale the infrastructure to meet our needs, mostly. I mean, of course, there are some gotchas there. I'll talk more about them later, but yeah, of course, we can scale the infrastructure typically to infinite levels. As long as AWS is happy to provide us instances, we should be able to scale them. ML scientists don't have to worry about ML platform architecture. All they need to worry about is model architecture. Of course, they need to understand how to build these pipelines and have some patterns. But once they get there, they don't have to really worry about how pipelines work and all that good stuff. ML and data needs are mostly met. We don't have to go to another service and do something to do some data processing. We mostly use Kubeflow for doing most of the data processing. We quickly even migrating some of our older workflows into Kubeflow to make the most of what we have here. And then Kubeflow SDK is really good. The current DSL works, and I'm really excited about the V2 SDK that's going to come soon. One of the features that I really like or we really like in the Kubeflow SDK is the transformers. If you haven't used it, go try it out. They are really awesome. They can help ops teams manage infrastructure in a better way, and also they can help machine learning engineers to build out these predefined plugins that they can use within their pipelines. They're pretty cool. So some of the awesome things that we've done with transformers are around container build process, right? So when you talk about pipelines, you have this specification, you have this pipeline definition, and you also need to build these container images that go along with it. If you go and watch YouTube videos, you're going to see a pipeline that uses the basic TensorFlow image or basic Python image, and then you write this simple function, then you go run the pipeline, and yeah, everything works. But that's not always the case. If you're talking about real world pipelines, real world code bases, they are complicated, they are complex. You need to build your own Docker images because some of your dependencies might not run in the regular or default images that are provided by Kubeflow itself. So in those scenarios, you need to build these Docker images into a system somehow, and you need to have some kind of pattern to keep track of like how these Docker images have been built, what code went into them, or what configuration went into them, and all that stuff. So we built a pattern for ourselves that allows the ML scientists, ML engineers or scientists to like define the components and Docker specifications within those component directories. And then we have this transformer that actually builds these images out, pushes them into appropriate Docker registry, and then whenever the pipeline comes, pushes the pipeline to KFP. Whenever the pipeline comes up, it knows where the images are, and the user doesn't have to know about how do I build this Docker image, where do I store them, how do I ensure that this URI for the Docker image exists within my Kubeflow pipeline definition, and all that stuff. Everything is automatically taken care of for them. Some of the other things that we do with transformers are with constraints and tolerations. If you have used Kubeflow pipelines or any Kubernetes infrastructure for that, you might have noticed that you need to add tolerations or constraints to run your infrastructure in particular instances, or you need to have some kind of default settings that you might want to run. Some of our favorites are around, we've divided our node groups in such a way that each node group has different type of instance. So users can have this flexibility of saying, oh, I want to run this job on CPU small, and it goes and gets scheduled in a particular node group. In those scenarios, some of these constraints can be set by our transformer automatically, and that way they don't have to figure all of that by themselves. Like let's say maybe your Kubernetes infrastructure has different node groups, and you don't want all components to run in all node groups. Maybe there are separate node groups where you want to run some special pods. In that scenario, tolerations are your friends, right? In scenarios like that, it actually helps you to create this default transformer and apply it to your Kubeflow pipeline, and all your components within that pipeline will run appropriately. Okay, so now let's talk a little more about the challenges that we had. And of course, you're going to see more challenges here than what we love. The reason being simply, when things are working, you don't really have an issue. When things are not working, those issues actually look a lot bigger. All of these things here that I mentioned are really important. If any of them were a little unstable, it would have made me feel like, okay, this is not a good platform, but they're all actually working well. But here we have a higher list because like these are the things that don't work, which doesn't mean that everything is broken. It only means that some of these things don't work, and we have workarounds for them. But instead of workarounds, it would have been nice if we had something out of the box. So when we think about Kubeflow, we definitely need to think about Kubernetes. If you're from an organization where you manage Kubernetes clusters and you have heavy experience, I think this slide is not for you. Just ignore this. This is more for someone who is some teams who are not really used to Kubernetes infrastructure, who come from a managed service world in the cloud, or who come from serverless world and try to adapt Kubeflow infrastructure for their needs. So in that scenario, right, as you already might know, Kubernetes is not really built for batch workloads. Of course, this is changing. Things are evolving in Kubernetes world, but initially it was not built for that purpose. I mean, there is this famous thing, right? Cattle and pets. Treat your instances as cattle, yeah. So it's something along those lines. Like if your pod, when it comes to the Kubernetes world, the pods are mostly stateless, or at least the pods are mostly stateless. And if they die, and the other pod comes up and it serves the request. But when it comes to batch world, if you're running a training job and it's running for like 7 days or so, if the job runs right, job fails right before seventh day, then you're going to lose all the work. Of course, there are different ways you can resolve it. You can have some kind of checkpointing involved, but it's not the same experiment anymore. Things will change. So when you're doing batch workloads, you definitely want to have the workloads run properly rather than like dying in the middle or being deleted, terminated by the infrastructure. I'm not saying this happens every time. Of course, there are workarounds to make sure that your batch workloads are taken care of by Kubernetes properly, but I'm saying out of the box, that not seem to be the case for me. Managed K8 offerings are not really managed at this point in time. Of course, again, this is debatable. In my opinion, there are like two types of people. The first kind is where they want a Kubernetes service to be as customizable as possible. They want to change everything and anything. They want to write their own cluster autoscaler and all that good stuff. Yeah. So that for that school of people, managed services right now are pretty good. And there are people like me who come from serverless world or managed service world, and we don't really want to manage most of the things that usually cloud providers provide. Like for example, we want cluster autoscaler to be managed by the cluster itself, rather than us trying to manage it. Or we want to attach to a EFS volume without having to do much configuration on the Kubernetes side. And this basically comes down to like how many members are actively working on Kubernetes within your team, how much can you spend, and all that good stuff, right? So for us, it would be better if managed Kubernetes is actually managed, and it's managed by the cloud providers, rather than us having to do some of the heavy lifting around some important components. Some of the important components here are cluster autoscaler, core DNS, right? I'll go more over them. So we have this workload. As I mentioned, we've been running Kubeflow for about 2 years now. Initially, we started out with simple pipelines. People started submitting them. They started scaling. We ran into some minimal issues. We've somehow fixed them. But as you scale up, you see some other use cases. Like one of the use cases we have is like we want to run this system level test using a newest model, but it has to scale up to like 200 pods running on like some instances. In that scenario, you might have like one or two of those pipelines running at the same time. You have to have this scale up happen pretty quickly and scale up happen as well. In those scenarios, once we started doing that, all of a sudden things did not work out. Of course, we had to learn the hard way because like things could go wrong around the Kubeflow world, where you might have to increase some resource limits, some resources on some parts. Like for example, we had issues with Istio, telemetry, Istio policy, where we had to scale them up just so that we can handle this kind of load. And there were issues around the Kubernetes side itself. Like for example, the cluster autoscaler did not have enough resources, so it just like fails. And we don't know what happened, and the cluster doesn't scale down. It can get expensive pretty quickly if you have a number of instances running. Or like we have issues around like core DNS. Core DNS, I feel like it's a core part of Kubernetes. What happens is whenever you scale up, core DNS deployments doesn't scale up, which means you run into this problem where your pods get into a phase where they cannot resolve DNS, a URL, and then all of a sudden things start failing. This usually happens because you have to either manually scale your coordinates parts, or you have to have another deployment that runs parallel to coordinates that will allow you to scale up and scale down coordinates based on the workflows that are running. So I feel like if you're a team, if you're a small team, and if you're looking for something that's kind of managed around the Kubernetes world, I don't feel like that kind of exists. The deployment and management tools, me coming from AWS world, we are very much used to CloudFormation. CloudFormation doesn't have direct support for Kubernetes service on AWS as well as EKS Scuttle has. Even EKS team ask their customer to use EKS Scuttle for managing Kubernetes clusters. EKS Scuttle is good. It is declarative. You can define everything, but the deployment process and management process is not that straightforward, in the sense that if you want to update a node group, you cannot update it directly. So you have to delete the old node group and redeploy that node group with a new configuration, which is kind of weird. And you cannot do cluster upgrade and node group upgrade at the same time. Again, this might be something that's really good for traditional Kubernetes deployment, who really customizing the cluster and all that good stuff. For someone like us, I don't think this was really straightforward. And Kubernetes is a fast-moving world, so you have to catch up with updates every now and then, which can be a little bit complicated based on what you have deployed. It's not the end of the world, but it can get a little bit crazy if your deployments are not supported by that version of Kubernetes. This is a problem with managed service or self-managed service in a way. This is something that we have to accept and move on. And then the network architecture can get complicated. As I showed you the network architecture, the architecture diagram, the network architecture, of course, is going to be complicated depending on your needs. Again, most of these things might not be applicable for you if you have a small team, and if you only have maybe 10, 15, 20 pipelines running at the same time, and the traffic to the infrastructure is not actually that great. Then in that scenario, you might not even notice these because the out of the box solution should work for you. But if you are at a scale where you're scaling up quickly, scaling down, you want to manage some of these things, you will be noticing some of the challenges that we had. Now that we had a conversation about Kubernetes challenges, let's talk about Kubeflow challenges. Around Kubeflow, documentation used to be really good, but recently the documentation update is not happening as much as it's supposed to, which can, the team can do better, but at the same time, it's an open source software. A lot of people contributing, building a lot of good stuff. So it's not easy. So that's kind of acceptable, I guess. Some of the other things are lack of documentation around best practices around deployment of the pipeline or Kubeflow infrastructure. This can get a little bit tricky, right? In our team, we found a workaround for this. We've done some workshops internally. We have some internal documentation, best practices, notebooks. We do have some samples to show people how to develop Kubeflow pipelines. So we've done some work around this. But even then, if there is something that's available from the community, where thousands of people are looking at it, that would be much more polished and much more easy to understand than something that's homegrown. And then operation side of things also, you need to get used to it. If you come from Kubernetes world, probably it's pretty easy for you. But if you're coming from a different world and trying to start using Kubeflow or Kubernetes, it can be a little bit daunting. Python slide. So when we integrated this SAML identity provider with our cluster, we had to make some modifications to the Python SDK so that our client can actually talk to the cluster and submit the pipelines or get the metadata, anything along those lines. So we had to do that work ourselves. It would be nice if something exists. I know Kubeflow in the last update, I think they added some support around this, but I haven't tested it. Hopefully that works, but when we deployed this infrastructure, we did not have that capability. Logs of the components vanish as instance terminates. I think some of you might have noticed this. If you have an auto-scalable node group, if the node group goes, whenever you schedule a pod, the node comes up, the pod runs it, and then let's say once your pod is done, the node group scales down and the node goes away. In that situation, the log vanishes from Kubeflow dashboard, which means, let's say someone has run an experiment during weekend. The experiment was done within the weekend, and Monday they come back and they look at the component. They don't see the logs anymore. That is kind of annoying. One of the workarounds we found here is to use FluentD to stream our logs into CloudWatch, which is AWS solution for tracking logs. It works pretty well, but again, we had to do a lot of fine tuning so that our FluentD works as we expect it to work. But one of the biggest issues is that you cannot directly click a button on Kubeflow and see the logs. You will have to do some shenanigans, copy the component name, go to CloudWatch, and then search for that log. UI can become non-responsive as pipeline graph gets complicated. This is not something that most of the people see. I think most of the pipeline graphs should be not so complicated, but it'd be nice to have an ability to run pipelines that are at a different level. I think with Kubeflow SDK v2, think some of these things will go away. Like being part of some of the community meetings, I got a sense that we are moving away from the Argo Argo workflow specification to more of Kubeflow native thing, which would help with rendering and everything. Hopefully that happens soon, and this goes away. Yeah, some of the other things are you don't have the ability to catch an error with a pod and just ignore it. So if you have this 200 instance or 200 pod pipeline, in that scenario, let's say if one pod dies because of some infrastructure failure or anything along those lines, your entire pipeline is deemed to be failed. In that scenario, you cannot go to the next step and can cause issues. It would be nice if we can ignore that failed component and move on. Of course, you can add retries, but retries can only help you in certain instances. If the infrastructure really failed and doesn't want to help you in those scenarios, having a try-catch kind of a thing would definitely help. And updating between different versions of Kubeflow is also an issue without causing data loss. It makes you think do I really want to go to this new version, or do I just kind of stick here and wait for some more time until the next release? Especially because of the data loss it can cause, the metadata can go away unless you migrate all the data, which can be very annoying to lose metadata. Anyway, so that's the talk I wanted to present today. I hope you've learned something from our experience. Kubeflow is a great tool. Don't get discouraged by the challenges that I mentioned. It provides you a lot of value. If you're a smaller team, you will not even see some of these things that I mentioned. If your number of pipelines you run on the infrastructure is low, but if you are planning on scaling it out, make sure that you at least have someone working on this at least 50% of the time. Of course, as they work and mature the deployment, some of these things will go away. But keep in mind that it might take someone to spend 50% of their time managing this infrastructure and making sure it gets to a level where it's very stable. Thank you. Thanks for patiently listening to my talk. We are hiring at iRobot. There are a lot of positions open. So if you're interested, please go to this website and you should be able to find a role. We do a lot of cool things with robots, so you definitely enjoy working with us. If you have any questions regarding this talk or anything along the lines of Kubeflow, feel free to contact me on LinkedIn. I should be able to reply as soon as I can. Thank you.
Thanks for such an amazing presentation, Mohan. It was definitely great to hear about that and learn about those things happening at iRobot. Unfortunately, we don't have any time for Q&A, but we do have an amazing live panel coming up next. I would have Simon, Stefan, Adam, and Monacy herself on it, so I will post the link. Be sure to head on over there, and we look forward to seeing you all there. Thanks.